If you're running your business through the cloud in 2026, you've already lost your privacy. The courts just ruled that anything you send through a commercial AI tool, your strategy, your prompts, your IP, it's not privileged. It's legally vulnerable. You're essentially handing your trade secrets to the government and your competitors on a silver platter. Today, we're stopping the bleed. I'm taking SharkGuard operational. It's an AES 128 encryption engine that keeps your files on your hardware, sealed up and locked behind a key that only you hold. If you aren't encrypting locally before you touch the web, you aren't going to be a leader. You're just going to be a target. And I'm giving this SharkGuard away on my free Tentacles GitHub repository, complete with the CLI, the Docker, the README, and the Python code. So you can run the tests or actually use the key. It's up to you. So stick around. We're going to build the CLI today, and then we're going to get that pushed out to free Tentacles. All right, so now we're building the command center for SharkGuard. With SharkGuard already tuned and ready to go, we now need the CLI, the interface. So we're going to start with the scaffolding. And Typer is a library built on top of another library called Click. It uses Python type hints to automatically build your CLI. So a weak developer is going to write a script that uses this.argv and a bunch of messy if-else blocks to figure out what the user typed, where a system architect is going to use a framework like Typer because it's self-documenting. It automatically generates the help screens, ensuring your sovereign tools are easy for other elite engineers to use. This creates our app object. It's the brain of the CLI. Everything we build from here on out will be registered to this object. So Typer is the class used to create the main entry point. By passing the help argument right at the start, you're branding your code at the root. In Python, anything starting with an @ is a function that wraps another function. Decorators are an architect's best friend because they keep the plumbing separate from the logic. The @app.command is a decorator that handles all the heavy lifting: terminal communication, argument parsing, help text generation. It is clean, modular, scalable. Obviously down here, it's a standard Python guard. It says only run the code below if this file is being executed directly, not if it's being imported as a library by another script. So this makes our code hybrid ready. It allows Jelly CLI to be a standalone tool today, but tomorrow it can be imported into a larger Bloom tier ecosystem without the CLI starting up automatically and crashing the bigger system. All right, from rich.console, we are bringing in Rich for the visual engine. So an architect doesn't just use print. We use console because it queries the hardware's color capacity before sending a single pixel. Passing the help argument here, like I stated before, ensures that the brand's manifesto is the very first thing that a user will see when they run the help function. We're using panel.fit. This is a method that wraps a border tightly around text. Standard panels look flat, so .fit creates a tactical widget look. We use Jelly Neon, the hex code here, for the title, and Jelly Cyan for the border, which establishes the high fidelity aesthetic. This uses the app.command, which is a decorator which allows us to register the function as a terminal command. We use the shark.hideAnchor call in a console.status spinner. In an offline first setup, this biological pulse proves the hardware is actively generating entropy. We pull the genetic material of the string key in a C. The drift command is the only time the invisible key is shown to the human. We use a dedicated Jelly Neon in order to isolate it, which signals its critical importance. Typer.argument none allows the user to pass the seed directly into the command line. We use prompt.ask as a fallback. This is terminal agnosticism. The code works for both automated scripts, arguments, and human users. This is the most critical part of the build because we are moving from text to protecting assets, files, and folders. So we take a target string and we immediately wrap it in a path object from the pathlib library. A weak development may use strings for file paths, but because we're looking to be more high level than that, we're going to use path objects because they work identically on Windows, Mac, and Linux. Path.rglob stands for recursive glob. It searches the folder and every subfolder inside of it. IsFile ensures we don't try to encrypt a folder name, but only the files inside of it. Not .file path .suffix equals shark is a safeguard so we don't accidentally encrypt a file that is already protected. One command secures 10,000 files. We use the jelly purple, a status spinner, to show the shark is hunting through the folders. If the target isn't a folder, we check if it's a single file and we pass it to our helper. We use success green here because the user successfully created an apex tooth for that specific asset. With open file path, read binary as f, we are reading the raw bits, not just the text. Data.decode errors equals ignore converts binary data into a string for the current Shark engine, all while skipping characters that might crash it. And with suffix, this creates a new file name, like doc.txt becomes doc.txt.shark. This helper here, the secure file, keeps the plumbing separate from the logic. It handles the dirty work for the input outputs so the main clamp command stays clean. And this reverses the process. Path.with suffix, it strips the .shark extension that we talked about earlier to restore the original file to its original name. This is the hardware handshake. If the machine's DNA doesn't match the file, the engine will trigger a syndicate alert and refuse to write the data. A table object is to organize the diagnostic data. We align the first column to the right with a clean spine down the middle of the terminal. Using this success green here for the border tells the user subconsciously that the system is healthy. Create the Dockerfile, we need our requirements, and then we save our Dockerfile. We're gonna demo this out, status, and there we go. So we aren't guessing. We are querying the hardware. The Shark has sensed the unique DNA of this workstation and verified that the habitat is healthy, which we see in this success green. Look at that sensing column right there. That hex code isn't a random number. That is the hardware DNA of this specific workstation. So SharkGuard has sensed the physical pulse of the machine to ensure that the encryption that we have is locked to this metal and nowhere else. Python sg.py anchor. The Shark has claimed this workstation. So tide number 1 is the anchor. We aren't just generating a random key. We are growing an apex tooth, a .sting key, which is mathematically inseparable from this specific machine. If you move the code, tooth stays behind. The Shark has officially claimed this workstation as its home. sg.py drift. So as you can see, our remora seed was secured because the drift function has a zero backdoor architecture, so we have no forgot password button. Instead, we extract the genetic material of our key into a remora seed, which I explained in video 1. And this is your sovereign backup. This is your fail safe. If this workstation is crushed or the drive fails, this seed is the only bridge to get back your data. So copy it, keep it offline, and treat it like the DNA of your business, because whatever files you have protected with it, it is. If you lose this key, if you lose this seed, your data is gone. So now we have to enter our remora seed. Okay, now we're gonna simulate the disaster where we remove our sting key. And now that my sting key's been deleted, I'm not going to be able to access my data. So in any other system, this is where you'd be locked out forever. This is the black hole effect. Once you delete this, your data is gone. And so let's see now if we can regrow a tooth using our remora seed. And that's what the sonar function is for. So I got my remora seed here, and let's now run Python sg.py sonar. Let's run sonar. As you can see here, it wants us to enter our remora seed, which we saved. And just like that, you can see that our remora seed, or our sting key, was restored thanks to the fact that we had our remora seed. So we used our genetic backup to restore the hardware handshake. We're back online without ever touching the cloud. Okay, so now that our sting key is restored, we're going to clamp this intelligence here. We're going to clamp intel.txt. And now that the file is clamped, we want to try to attack it. So as you can see, the file was clamped, and without this specific workstation, without this hardware and its regenerated tooth, the file would be mathematically dead. And now what happens is we can remove our .sting key, and now our key is gone. Now we need to try to access this. Python sgpy release intel.txt. This is what we were looking for. We wanted to see that error, the DNA handshake failed and our access was denied because we don't have a key. Now we need to use sonar to restore it because that is our recovery method. Now if we want to recover it, we need to use our remora seed, which luckily I have a screenshot of because we would not be able to remember this. Double check it, And now our sting key has been restored. Now we can go and release the file. So when that sting key was destroyed, the data was mathematically dead. Using our remora seed, now we want to try to release it and see if it will release. And we have to add shark at the end because remember it's been encrypted. And there it is. The nutrient was restored. It has our private strategy information on it, all because we had our remora seed and we were able to recover. So it protects our data. It allows us to access it when we have the key. If the key is missing, then the data stays on our metal and nobody has access to it. If we want to, we can recover it. And in the meantime, our drift function allows a temporary key to be used for new data, but the old data is still attached to the old key and dead. So I'm going to upload this to my free tentacles repository. You can go and download it, the CLI, the Docker, the Python code. You can import SharkGuard into your own stuff and use it how you please. Just remember, you're responsible if you attach data to this and you delete your key or lose your key. Your data will be gone. Other than that, it's free. It's an AES 128 encryption key. You got to protect your data now, especially everything is legally vulnerable in the cloud. So now's the time, and I'll see you in the next build.